Thorlabs Vitran LDC cleavers are capable of high precision cleaving of glass fibres, with diameters ranging from 80 micron to 1250 micron cladding. In this video we will describe how to reposition a cleave blade so that a new sharp section touches the fibre. Blade replacement will also be covered. The cleavers use a tension and scribe technique. The fibre is placed under a known tension. A diamond cleave blade then moves gradually forwards in a pecking motion until the blade just strikes the fibre, causing it to cleave. For more information about performing both flat and angled cleaves, please click on the annotations to watch the videos and learn more. During cleaving, only a very small section of the blade comes into contact with the fibre. A single section of the blade can remain sharp and produce over 5,000 good quality cleaves over time. However, if the cleave conditions are not optimised for a specific fibre type, for example the tension is set too low, the fibre may flex rather than cleave when the blade touches it. This will result in lateral stress being applied to the blade, and it will become dulled or damaged prematurely. If the cleave quality becomes suboptimal, first try the approach described in the basic maintenance and cleaning video. If this does not restore the cleave quality, the cleave blade should be repositioned or replaced. When repositioning the blade, it may be helpful to use a piece of fibre as a reference. Use the handset controller to either load or set up a cleave file for a standard fibre size which matches your reference fibre. For example, for 400 micron cladding and 550 micron coating, Thorlabs FG400LA could be used. The auto parameter tool on the handset should be used to ensure that the correct cleave tension and pre-cleave advance are set for the reference fibre's diameter. Before loading the reference fibre, ensure the micrometer backstop is fully retracted. Alternatively, the 4 screws securing the micrometer may be undone, so that the micrometer can be removed totally if preferred. Now secure the reference fibre in the left fibre holding block, using either a transfer insert or by closing the left fibre holding block lid. Do not clamp the reference fibre in the right fibre holding block. This will prevent damage to the blade when it is moved to the service position. Use the handset controller to select Tools, Blade Service. This will cause the blade to move forwards from its home position to the service position. The cleave blade is located in a black housing with ruler markings. The 2 screws at the front clamp the housing in place. The screw on the top of the housing is used to adjust the height of the cleave blade. With the cleave blade at the service position and the reference fibre in place, the position on the blade edge which strikes the fibre can be seen clearly. Use an eye loop if necessary. To reposition the blade, first, using a 3/32 hex key, loosen the 2 clamping screws on the front of the housing by turning them by about half a turn. Now, using the same hex key, turn the screw on the top of the housing clockwise by about 1/4 of a turn. This will raise the cleave blade so that the fibre will be struck by a new unused section lower down the blade edge. When the adjustments to the blade position are complete, ensure the front 2 clamping screws are retightened to secure the housing. To access unused sections on the very lowest part of the blade, it may be necessary to rotate the blade through 180 degrees. To do this, loosen the set screw in the top of the cleave arm using a 35 thou hex key and rotate the blade through 180 degrees so that it is vertical by eye. When in position, retighten the set screw. To reposition the fibre towards the top of the blade, turn the adjustment screw counterclockwise. It may also be necessary to push down on the black hood over the blade to fully return it to its lowest position. The fibre will now be positioned at the top of the blade. The adjustment screw can once again be turned in a clockwise direction, moving the blade up, to access striking positions lower down the blade edge. Once the blade height has been set to the desired location, retighten the clamping screws on the front of the housing. Do not over-tighten. Then use the handset controller to return the cleave blade to its home position. When repositioning the blade, avoid positions where the fibre is struck by the very top or very bottom of the blade. It is good practice to keep track of the blade position and which sections of the blade are used and unused. The blade index parameter on the handset can be used to indicate the number of times the cleave blade height has been adjusted. As the position of the blade has been adjusted, the blade offset will also need to be checked. Please see the separate video that describes this process. Once the blade has been repositioned and the blade offset verified, the cleave performance can be checked by observing the cleaved fibre on an interferometer or using a glass processor. The cleave blade will need to be replaced if it has been damaged or if a new sharp, unused section cannot be selected by repositioning or rotating. Move the blade to the service position. This will allow the set screw in the top of the cleave arm to be accessed and loosened with a 35 thou hex key. It may be helpful to place a small section of wipe on the top of the nulled cog under the blade to catch the blade if it falls. The hex key can then be inserted through the hole in the back of the cleave blade housing. Nudge the cleave blade forwards, but not out of the cleave arm. When it is further forward, the blade can then be removed by holding the shaft using tweezers. A new cleave blade can then be inserted into the hole in the cleave arm. Use soft tip tweezers to hold the new blade on the metal section behind the diamond edge and insert the shank as far as possible into the bore of the cleave arm. Rotate the blade so that it is vertical by eye and retighten the set screw. The blade height will now need to be set, as described earlier. Typically, when a new blade is installed, the blade height is set so that the fibre will be struck at the very first section at the top of the blade. The blade offset will also need to be checked after the blade has been replaced. The cleave performance can then be verified by observing the cleaved fibre on an interferometer or using a glass processor. If you have any questions or concerns, please email us either at techsupport@thorlabs.com or vitran.uk@thorlabs.com.